In this lab, we're going to look at different HTTP response codes and also use TCPDump to check these response codes within BigIP, and also look at the monitoring traffic of BigIP. This is the lab setup we will be using. We have this Fortinet firewall connected to this inside network with the IP address of 10.1.10/24, and within the DMZ we have this F5 BigIP that's configured to load balance between those three web servers. HTTP response codes have different categories depending on what number they start with. The first category are informational responses. The second category is for successful responses, and they start with the number 2. These are used whenever a request is processed successfully by the server, like the 200 OK message. The third category is the redirection messages, which is used whenever a client is redirected to some different URL. The fourth category is the client error responses, and this category defines errors that happen because of an issue in the request sent by the client, like the 404 error, which shows when a client requests a resource that doesn't exist in the server, or the 403, which is the forbidden when a server denies permission to access a page. The last category, which starts with number 5, is the server-side error responses, like the 500 internal server error or the 502 bad gateway. Here is the lab setup, and if we go to the BigIP, to local traffic and then network map, here we have this virtual server configured with the IP of 10.1.30.33, and here is the pool with the 3 web servers. And in the FortiGate, we will log in with a password. If we go to policies and objects and policies, we have 3 policies configured. Number 1 is the outside to DMZ, which allows the outside users to browse these DMZ web servers. The second is inside to outside, which allows the inside users to browse the internet. And the third is the inside to DMZ, which allows the users on the inside network to be able to browse the DMZ web browsers. So first we will open the BigIP CLI. And we will type TCPDump command to listen on the external interface of this F5 BigIP. So TCPDump interface external VLAN. So we will write external. And then our host IP is going to be the IP address of the virtual server. So 10.1.30.33. And we are gonna be looking at port 80 for HTTP. Now it's listening on the external port, so if we go to the web browser and type 192.168.100.33, which is the IP address that we're using here to NAT within the BigIP, we are mapping this IP to the local IP address of the virtual server. We've got server 2, and if we look back here, we can see the 3-way handshake. This is the first SYN packet sent from the firewall's IP address to the virtual server's IP address. We can see that it's a flag S, which is SYN. And then we've got this response from the virtual server's IP address to the firewall's IP address. It has sent a flag S with acknowledgement. And also lastly, we have the last acknowledgement from the firewall's IP address to the virtual server's IP address. Then here is the request. We've got HTTP GET request. And in the response, we can see that we've got the 200 OK message or code, which shows that this was a successful response. Next, we will try to type something wrong and try to get the 404 error, which is for the page not found. So we will add index.php, and now we've got page that says 404 not found. And if we start listening again and try to do this again, here we've got the traffic, and if we go up, we can see that in the request we've got this HTTP GET for index.php, and in the response it shows that there is 404 not found. Next, we will try to get the redirection error. So we will first go back to the big IP, go to Profiles, and go to HTTP. And here on the fallback host, we will set the URL of Google. Then this is going to redirect us to Google if all the members of the pool are not set. So we will update this and then go back to the pool, open the web pool, and go to members and press all members and disable them. And this time we will try to access from the inside users. So we will go to PC1, open Firefox, and also start listening before we send the requests. So we will turn this off, then start listening again, and then we will type the IP address, which is 10.1.30.33. And now we are redirected to Google. If we look here into the request, we will see that we've got the HTTP GET, and in the response it shows 302, which is for redirection. So now we've seen the 3 examples of HTTP code responses, and I have used this HTTP fallback just to show the redirection, but its use cases is in case where you have maintenance going on or you have something going on with your servers and you need to send your users to an apology page or like to another alternative website. So in that cases you use that fallback within the HTTP profile. Now that we've seen all these codes, we are gonna go and try to see the monitoring traffic of big IP. So if we turn this off and turn on all these members, enable them, go to properties, we can see that the health monitor of this pool is TCP half open, which means it's doing a half TCP connections with each of the web servers, which means it will send first a SYN, receive a SYN ACK, and then it will just reset the whole connection. If we go and say TCPDump and then set the interface to internal, and the host is going to be the IP address of the internal port of big IP, so it's going to be the IP address of 10.1.50.200. We will write 10.1.50.200 and port 80, and wait a bit for the traffic to come. We should receive the health monitor checks that are going between the big IP and these 3 web servers. So here we got the first one. The big IP is sending a request to HTTP to server 1 on port 80, and then the big IP is receiving a SYN ACK. Here we have it, the SYN ACK from server 1, and then we can see that the big IP is sending a flag R, which stands for reset. And then we see the same again with server 2. So here is the big IP's IP address with server 2's IP address, and here we've got a SYN flag. Again, we have the same with SYN ACK, and then finally the big IP is sending a reset flag, and again same goes on with server 3. Here we can see the IP address of server 3 responding with SYN ACK, and again the big IP is sending a reset flag, and it goes on like this to make sure that these servers are all available. And if we just change the health monitor to something else like this gateway ICMP and update, and then go back and type the same command but change port 80 to ICMP, change port 80 to ICMP, and now that we're listening, we should get ICMP traffic. Here they are. Here we can see the IP address of the big IP sending echo request to server 2, and it received an ICMP echo reply from server 2, and then again it's sending another echo request to server 3 and receiving a reply from server 3, and the same goes on with server 1. It's sending an ICMP request and also receive a response, and this way it used ICMP echo to make sure each of these servers are alive. You can use also Wireshark to do this with a graphical interface.